question using the property. Now it becomes 0 to pi by 2, pi by 2 minus x, sine pi by 2 minus x, cos pi by 2 minus x upon sin pi by 2 minus x plus cos pi by 2 minus x dx. Integration of 0 to a fx dx is equal to 0 to a f a minus x dx. We have used this property. Now question becomes zero to pi by 2, pi by 2 minus x, cosec sin x dx upon cos 4x plus sin 4x. Now this can be written as pi by 2, 0 to pi by 2. Sin x cos x dx upon sin 4x raised to power 4x plus cos raised to power 4x minus 0 to pi by 2 x sin x cos x dx upon sin raised to power 4x cos raised to power 4x. Pi by 2, 0 to pi by 2 sin x cos x dx cos raised to power 4x minus I. This is the question. Now this can be written as now 2I is equal to pi by 2, 0 to pi by 2. Now to this part, you can write it sin x cos x dx upon cos 4x taken common, and we are left with tan 4x plus 1. Okay. Now this becomes pi by 4, 0 to pi by 2 tan x secant square x dx upon tan raised to power 4x plus 1. Now what we have done it, we have cancelled one cos x with one of the cos x, we are left with cos cube x. Now sin x upon cos x becomes tan x and 1 upon cos square x becomes secant square x. Let tan square x is equal to t differentiating with respect to x 2 tan x secant square x dx is equal to dt. Now when x is equal to 0, t is equal to 0, when x is equal to pi by 2, t is equal to infinity. Pi by 4 0 to infinity 1 upon 2 dt t dt dt upon t square plus 1. Is it clear? Now this becomes pi upon 8 tan inverse t 0 to infinity. Pi by 8 tan inverse infinity minus tan inverse 0. Pi by 8 tan inverse infinity, now it becomes pi by 2 minus 0. Pi square by 16 answer.